Okay, we wait another 5 minutes. Okay, we wait another 2 minutes. Okay, 10:35 we will start. And hey, hello everyone. Good morning. Okay, so today I think we are going to finish our chapter 3. Okay, so if let's say we can finish earlier, then maybe we will stop earlier a little bit. Okay, and please remember that next week, 26th of May, we won't have any online class. It's your holiday. Okay, but the week after that, 2nd of June, you must come back already, because we will do revision for chapter 3. Okay, so everyone ready? Okay. Hello. Teacher not holiday meh? Yeah, it's holiday ma. That's why I let you off. You all off 1 week ma. Next week lah. Next week. Really 2nd of June I say holiday also 2 weeks Let me see. Miss Pauline say Okay lah, like this lah. But on 2nd of June, okay, I will give you the answer of the revision chapter 3 online. Then you all check. Okay, so next week before we start, I think better never mind. Okay, 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 okay. Okay, follow Takwim. Okay, 2nd of June also no class. Okay, we will resume back our class, online class on 9th of June. Okay, class can. No problem, So 2 weeks no class, Please tell your friend who didn't come today, Today only got 26, Tak tahu siapa pergi mana sudah. Okay, like, come, let's see. So last week we already start a little bit of transformer. Okay, what is transformer? Anyone can tell me or not? Anyone? Hello? 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 No one tell me. Help. Okay, step up and step up. Correct. Okay, is to either step up, it will be increase or decrease the voltage of what? A DC or an AC? DC or AC. Very good. It's an alternating current. Remember, transformer only works on alternating current. So this is how what the symbol of a transformer. Okay, so here you will have the primary voltage, okay, which is what we call it as input voltage, okay, input voltage. Then this one is the primary coil, okay, then this will be the secondary coil and also the secondary voltage, which also we will call it as output voltage. Output voltage. Okay, so we have two types of transformer. One, it will be step up transformer. One, it will be step down transformer. Okay, okay, by the way, in a transformer, the input power, okay, and the output power, it will be the same. Okay, it will be the same, just that the difference, it will be in the voltage and also the number of turns. Okay, number of turns in the coil. Okay, so anyone, can you tell me if let's say I say this one is step down, this one is step up. Okay, for MP is greater than NS, is a step down transformer or a step up transformer? You just write up. Oh, sorry, this one is up. This one is down. Okay, if let's say first one, your MP is greater than NS, correct, it will be a step down transformer. Okay, if let's say the voltage of your primary is less than the voltage of your secondary voltage is greater than your primary voltage, correct, it is a step up transformer. Thank you, everyone. Thank you, the one that draws so big arrow there, Okay, so this is what we have learned last week. Okay, then we can know about the ratio of a primary voltage and number of turns, and also a secondary voltage and turns by using the formula NS over MP equals to VS over VP. The ratio of here, it will be the same, okay? Because you must know this formula, then only you can do well in the exercise that I have asked you to do, okay? The exercise 3.4, okay? By the way, I didn't see anyone pass up, but please pass up today lah, I think today we can discuss it, okay? Can, at the moment, any problem? Okay, no problem here. Very good. Okay. Alright. Okay, let's come back to our this one. Okay. So this is the one. Why I did? Why? Okay, never mind. I got you all wait me a while. A while only. Please wait me a while. I want to show you something. Chapter 3, 3.4. Ooh. Y'all go out for any lunch or dinner already yet? Remember to wear your mask. Huh? Go everywhere also must wear mask. Huh? Why not here? Oh, then it's not here already. Why? Anyone want to tell me something? Of course, happy lah. Long time didn't go dating already leh. I even went to IKEA. Yeah. But good leh. Now if you go to IKEA now, there no one there one. You must go early in the morning lah. Then it's like the whole IKEA is like you own it like that. Good also lah. And over there you can like how you can dine in also. Then they got check your temperature everywhere. Also you can find hand sanitizer. So it's quite safe lah, I think. And but for remember is once you go back home, you must wash lah. Wash and yourself entirely. Okay, go out. Then your license then can go out already lah. Okay, like come. Don't you feel that today I'm more cheerful already, man? Because I can go out already, man. Okay, come. Let's see here. Why I cannot see my chat? Oh my god. Okay, my chat got problem now. Anyone, if you want to ask any questions, okay, please open up your mic because I don't know why my chat sometimes nowadays not very working. Okay, so last lesson we stop over here, okay, in a power plant supply, we must have a step up transformer in order to increase the voltage. Okay, to increase the voltage so that it can transmit it in the high voltage transmission line. So once it reaches right before the household users, we will use a step down transformer to reduce the voltage, okay, of an AC so that it can be used for a household. Okay, so this is an experiment. We want to see that, okay, if let's say there is here you have two bulbs here. This is a residential one. Then this is a power station one. And over here, this is a power station with, you will have a step-up transformer here. And across the transmission line, here is a step-down transformer and the residential area. So for the Model A, without the transformer, you can see that when the brightness reaches the residential area, it will be dim. Why? Because the power is too high already. The power is too high. Or in another words, if let's say you didn't step up the voltage, once it passes through this transmission line, it will have the tendency to lose in power. Okay, to lose in power. Okay, to lose the power. Okay, so to prevent the loss of power, we must make sure that the current, okay, the current transmitted is in low. Okay, is in low. Okay, why is it I say so? Okay. So, oh, thank you very much, Mokriti lah. I know that. Okay, now my chat is back already. Okay, so as you know, okay, to find power, if let's say involving voltage and current, it will be V and I. Okay, V and I. Okay, so in order we want to find the relationship between voltage and current. Okay, so we put the V as the subject, then P over I. So in another words, if let's say in a transformer, as you know, in a transformer, your power, it will stay constant all the time, whether in input and also output. Okay, input and output. Okay, can say so like input and output like that. Okay, so which means that here, okay, in order to reduce the current, okay, because we want to make sure that the current is transmitted, the current transmitted in this transmission line is low, so that to prevent more power loss, okay, to prevent more power loss. So in order to reduce the current, we must increase the voltage. So how can we increase the voltage? By using a step-up transformer to increase the voltage, okay, to increase the voltage, okay. So that's why if let's say in model A, without the transformer, the voltage is not increased, then during the transmission line, the power, it will be lost, okay, the power will be lost. So once it reaches the residential area, then you will see that the bulb is light up dimmer, okay. But on the other hand, in model B, you have a step up transformer here to increase the voltage, okay. To increase the voltage already, then it will help you to reduce the power loss in the transmission line, okay. But once you step up, you must reduce it down so that it's suitable for the household use, okay, suitable for the household use, okay. So if you say you see here, this one is 1 to 12, which means that this one, the 12 volt, okay, the 12 volt, it has increased into if I'm not, please wait a while, okay, please wait a while. Okay, so now it's 1 to 20, 1 to 20, okay, so 20 times 20, 12. So which means that here, the transmission of the voltage here, it will be 240 volt. Okay, how do I know that? I just use the formula, okay, MPNS over ME equals to Vs over Vp. Okay, so here, since I know that this one, the ratio of this one, it will be 20, so I just put in the 12 volt here. Is the primary, then so this is the primary, and the secondary we will find it here. Okay, so since the voltage you transmitted is 240 volt, before it reaches the residential area, this voltage is too high for the residential area to be used. Okay, it will cause this, okay, this bulb is not only light up dimmer, but it will blow off. Why? Because the voltage is too high already. That's why we need a step down transformer to reduce the voltage so that it can be suitable for the residential area use, which is here you see the output voltage here is only needed is 12 volt. Okay, can clear? Okay, so this is the purpose why we need the step up and the step down transformer in the transmission, in the electricity transmission. Okay, to prevent the loss of the current. Okay, to prevent the loss of power, so that so that's why the transmission must be carried out in the low current. Okay, low current. Okay, so next it will be here. Okay, I think this one, never mind, this one no need. Okay, okay, so efficiency of a transformer. Okay, we have learned about the efficiency in a lot of a few chapters beforehand. We will be, for example, your chapter 2 from 4, okay, about the power efficiency. Okay, this one last lesson, what is the notes already? Which number already? Which number we are in transformer? Nema, you can write in the chat already. I can see your chat now. Number? Number? Okay, now 6 already. Okay, so this it will be 6. Okay, efficiency of the power. So you just write efficiency of the transformer. You write this one can already. Okay, you just write this formula. Okay, to find an efficiency, okay, in a non-ideal transformer, you will use the useful output power divided by the power input power times 100%. But in an ideal transformer, actually the efficiency, it will be 100%. It will be 100%. So in another word, that's why I said just now, your output power will be the same as your input power, but in an ideal transformer. Sometimes in the question, they will say about ideal transformer. Why? Because they are telling you that the power is the same. Just that one part, the voltage is lower, one part, the voltage is higher. Okay? Because it is transformer. It helps you to step up or step down the voltage. Okay? So, but in practice, there is no ideal transformer. This is because there is electrical energy lost as heat. Okay, lost as heat. Okay, so in order for you to find efficiency, this is how you are going to do that. Okay. Okay, Ken? How many minutes left? 8 minutes, so should be okay. Okay, finish. Can I continue? Right, what? This one efficiency of the transformer, then this just this one will do. Okay, efficiency. This one will do. Mama. Okay, this one.
Teacher, the ideal transformer no need, right?
No need, no need. Because this is just for your information, okay? If let's say it's an ideal, once you see the word ideal, so which means that the input power and the output power, it will be the same. Okay, usually in exam, when you see ideal transformer, you must know that the both input power and output is the same. Then only it will help you to increase the voltage and decrease the voltage ideally. Okay, can okay, I continue Okay, so this will be the last part. Okay, so a reason loss. Okay, this everything I want you to copy it down as notes number 7. Okay, notes number 7, you write here 7 reason for the loss of the electrical energy. As I said just now, okay, in a real life, okay, in a real life, there is no ideal transformer because some of the electrical energy is lost as heat energy. So there are some reasons why is it that the electrical energy is lost as heat energy. So these are that, okay, these are the reasons. So there are 4 reasons altogether. So first, it will be the resistance of the wire, then the eddy current, and also the magnetic flux leakage, and also the magnetization and demagnetization of the core. So each and every of the reason, we have a way to reduce the effect. Okay, so that less energy, electrical energy is lost as heat energy. So we will look into it one by one. So resistant, okay, resistant, okay. So our resistance here, okay, of the wire used in making a coil, okay, as you know here, okay, wire, we will cause resistance. So resistance, it will produce a heating effect, okay, when the current flow through the coil. That's why it will help you to reduce by using a thicker copper wire. Why? Because thicker copper wire, bigger surface area, it will help you to reduce the resistance. Okay, resistance. Okay. Okay, if let's say you're talking about the length of the wire, is not accepted. Why? Because the length of the wire is already involved in the number of turns. So it is not the reason why the resistance, okay, it causing the resistance in the wire. Okay, so you must talk about thick copper wire. Okay, another one, it will be eddy current. Eddy current. Okay, eddy current is the current induced in the iron core. Okay, as you know. Okay, we have this one. Okay, this is the right over here. So this is the core. Okay, this is the core. Then we have the primary. Okay, then we have the secondary. So usually this core is made out of iron. Okay, iron core. And this iron core, okay, when there is a current passing through it, it will have the tendency to store some of the current inside the iron. Okay, and this current we will call as eddy current. We will call as eddy current. Okay, and this eddy current is the one of the reason why the electrical energy is lost. Okay, during the formation of the transformer, okay, the formation of the increasing or decreasing the voltage inside the transformer. So we can reduce it by using laminated iron core. So instead of using it, this iron core as a whole thing here, okay, so instead of using, okay, sorry, this is how am I going to draw, okay, so this is, if let's say you are not using laminated, it will be like this, like one whole solid over there. If let's say laminating means that you are using, the whole thing, Jen, okay, right, the whole thing, okay. So you will make it like one slice stick to one slice stick to one slice, like laminated like that lah. Okay, laminated means that like one slice sticking, then stick, making a core there like that. Okay, instead of using a whole solid part. Okay, so it will be one slice. Huh, Megan? Why is it? Okay, it's like a loaf of bread, without cutting. That one is a solid. Okay, once you cut it up and make it a loaf so that it's easier for you to eat, that one is laminated. Okay, that one we call it as laminated. It will help you to reduce the storage of the eddy current in the iron core. Okay. Okay, next it will be the magnetic flux linkage. As you know here, how this transformer work is like the cutting of the magnetic flux. Okay, the cutting of the magnetic flux at one part, then induces the current in the other part like that. Okay, so the magnetic flux produced by the primary current is not completely to the secondary coil. Okay, can be reduced by using a more compact coil. Okay, can be using a more compact coil. So which means that instead of you coil the primary at one part and secondary at one part, you can use another way. Okay, another coil which is made out of like this. Okay, we have a kind of coil which is like this. Okay, then your primary coil will here, secondary coil will be here. Okay, so since this is the coil is closer to each other already, it will help you to reduce the magnetic flux leakage. Okay, because it's right after it. Okay, so this is how we are talking about a more compact coil. Okay, a more compact coil. So the last one is magnetization and demagnetization. This one I think most of you know how to reduce the effect already. Okay, because as you know, okay, with this part, okay, this part, how is it increase produces the current is using produces the force is using a solenoid type. Okay, a solenoid type. So which means that you will have a iron core, okay, then coil with the coil head. Okay, so then the heat energy is lost during the magnetization and demagnetization. So in order to make sure that the magnetization and demagnetization, okay, can perform in a high level, so we will replace it using a soft iron core. Okay, soft iron core. Okay, so actually you can see that there's a keyword there on it, magnetization and demagnetization. Okay, when you see the word magnetization and demagnetization, there's only one way to help you to overcome this. It will be using soft iron core. Okay, soft iron core. Okay, can follow here? Okay, this one usually the question they will either in objective ICOS give you some of the example in the exercise 3.4 using the factors that affect the loss of energy. Okay, if not, if let's say in the structure question they will ask you how to reduce eddy current in the transformer, so you must tell the correct way. Okay, each and every reason it has its own way to overcome it. Okay, so you cannot mix around.